Hi guys, so we're continuing with solving systems of equations. We've already learned how to solve systems by graphing our two lines and finding where they intersect. We've learned how to solve systems by substitution, where we have x equals something or y equals something and we use it to plug it in or substitute it into the other equation. Okay, this is our last method and it's called elimination. Okay. And the idea is that since our equations have two variables, we can't solve for just one, right? What we have to do is that we have to eliminate or get rid of one variable. And when we do so, we can solve for that leftover variable we have. Okay? So we're going to start off with this system here. We're going to use the elimination method. Okay? So here you can see that my first equation is negative 4x minus 2y equals negative 12. Okay? And then my other equation is 4x plus 8y equals negative 24. Okay. So the first step is that we want a pair of same but opposite signed coefficients by either multiplying one of our equations by a number or both of our equations by a number. So that way we have opposite coefficients, okay? And so we see that for x, right? For my first equation, I have a negative 4x here. And then in the other equation, it's the opposite. Instead of negative 4x, it's a positive 4x. Okay? So I'm just going to write my two equations here. So it just so happens that with my first system, I already have my same but opposite signed coefficients, okay, for x, right? So here I have negative 4x and positive 4x. Okay? So what we're going to do is we're going to eliminate one of these variables by adding them together, right? And so because we have opposite signed but same coefficient for a variable, when we add it, it goes away, right? It ends up eliminating itself, right? So if I do negative 4x plus 4x, negative 4 plus 4 is 0, so I end up with 0x. Right? Then negative 2y plus 8y gives me 6y, so positive 6y. And negative 12 minus 24 gives me negative 36. Okay? When I do that, you can see that I have 0x now. So all I'm left with is 6y equals negative 36. Okay? Then easy to solve for y. All I have to do is get rid of that times 6 by dividing by 6. And I'm left with y equals negative 6. Okay? Now that I have y equals negative 6, I can plug it back in to solve. Right? So I'm going to plug in negative 6 for y here. Okay, so negative 4x minus 2 times negative 6 equals negative 12. Okay, then simplify. Negative 2 times negative 6 is positive 12. Okay. Then I need to solve for x, so I'm going to do reverse order of operations. So the opposite of plus is subtract. And then get rid of the times negative 4 by dividing by negative 4. And I get x equals 6. Okay. So you might be like, Miss Ng, you plugged it into the first equation. What if I wanted to do the second one, right? It would be the same thing. Okay, so let me choose a different color to show you that it would be the exact same thing, right? So for this one, I plugged it into the first equation. So let's say I wanted to plug it into the second equation for 4x plus 8y. Okay, so it should still be the same. Okay. So I'm plugging that y that I got here, y equals negative 6. I'm plugging it into my second equation. And you should see that it doesn't matter. I should still get x equals 6 in the end. So 4x, 8 times negative 6 is negative 48. Then to get rid of the minus 48, I'm going to add 48. And I get 4x equals 24. And then again, when I divide by 4, I get x equals 6. Right? So you can see whether, when you solve for the next one, whether you plug it into the first equation or the second equation, you should still get the same value. Okay? And then now all I have to do is write it as an ordered pair. So x equals 6 and y equals -6. So my final answer here is 6, comma, -6. And we're good. So let's move on to the next example here. So I have x minus y equals 11 and 2x plus y equals 19. Okay, so the first thing I want is I want opposite coefficients. Okay? So for this one here, this is a 1x and this is a 2x. Okay, so they're not the same, 1 and 2. This one here, I have a negative 1y and a positive 1y. Okay, they're both 1s for the y, and they are opposite sign, right? This one is negative 1y, this one is positive 1y. Okay, so I'm good to go, and all I have to do now is add the two equations. Okay? So 1x plus 2x is 3x. Negative 1y plus 1y ends up with 0y. And then 11 plus 19 gives me 30. Right? So technically I didn't have to write that 0y because 0 times anything is 0, so it's basically gone. Okay? And then now all I have to do is divide by 3 to get x by itself. I get x equals 10. Okay? So sorry, I'm just going to highlight. So here's our opposite coefficients. That's how I eliminate it. Okay? And then I just add them and then solve for the variable x equals 10. And then now, kind of like what we do for substitution, I'm going to take it and I'm going to plug it back in. Okay? So it doesn't matter which one you choose. Okay? It's still the same. So I'm going to take my x equals 10 and I'm going to plug it back into my original. Okay? So I'm going to choose to use x minus y equals 11. Since x equals 10, I can replace or substitute x with 10. And then I'm going to subtract 10. And I get negative y equals 1. Get rid of the negative by dividing by negative 1. Okay. And so my final answer is 10 comma negative 1. Okay. You can see that if I plugged it into the other equation, right, if I had chosen to do it for the second one, I should still get the same thing. Right? So if I plug in 10, into the second equation here, 2 times 10 is 20. Okay, and then to get y by itself, I subtract 20, and I get y equals negative 1. And you see it's the same thing. Okay, so it doesn't matter, right? And there you go. Okay. So let's look at the next one here. Okay, so here I have 3x plus 2y equals negative 6. That's my first equation. And then the next one I have 2x plus 5y equals 7. Okay, so if I compare 3 and 2, okay, these are not the same, right? And then 2 and 5, they are not the same either. Okay, so what I'm going to do is I'm going to multiply, right? So that way they are. Okay, so how can what can I multiply so that the 3 and the 2 go away? Okay. So what I'm going to do is I'm going to multiply this top equation by 2. And then since this will give me a 6x, in order to make this a negative 6, I'm going to multiply it by negative 3. Okay, so let's see. So I'm going to make sure to distribute. Okay. So 2 times 3x gives me 6x. 2 times 2y gives me positive 4y, and then 2 times negative 6 is a negative 12. Okay. Then same thing with the second one. Okay, I'm going to distribute. Okay, so negative 3 times 2x is negative 6x. Negative 3 times 5y gives me a negative 15y, and negative 3 times 7 gives me a negative 21. Okay. What you can see is that because I multiplied both of them, okay, I can see now I do have opposite but same coefficients. This one now is a 6x. This is a negative 6x, which means that when I add the two, I end up with 0x, meaning x's go away. Okay, and then continuing to add 4y and negative 15y will give me negative 11y. And negative 12 and negative 21 will give me a negative 33. Okay, so 0x is the same thing as just having it not there. So all I have is negative 11y. Divide by negative 11, and I get y equals 3. Okay. So now since I have y equals 3, all I have to do is plug it back in. Again, it doesn't matter which one. Okay, we've already seen that it doesn't matter which one you choose to plug it back into. You will still get the same thing. Okay, so I'm going to plug it into the first one. So since I had 3x plus 2y equals negative 6, now that I know y equals 3, I can plug it back in and solve. So since I know y equals 3, I choose to plug it into the first one. You could choose to do it in the second one. We should still get the same thing. Okay. 2 times 3 is 6, so 3x plus 6 equals negative 6. Get rid of the plus 6 by subtracting 6. Okay. And then get rid of the times 3 by dividing by 3. And I'm left with x equals negative 4. Okay. And so writing my final answer in ordered pair, x comma y. So since x is negative 4 comma 3. And that's my answer. And then if ever I'm unsure if I got the correct answer, I could always plug it back into my originals to check, right? And then just to show you that it works for both equations. Okay. Right, so my first one was 3x plus 2y equals negative 6. My other equation is 2x plus 5y equals 7. If I plug this point in, it should be true for both. So plugging in negative 4 for x and 3 for y. 3 times negative 4 is negative 12. 2 times 3 is 6. Negative 12 plus 6 is negative 6. Does negative 6 equal negative 6? Yes, it does. So it works for my first equation. Okay, checking to see if it works for my second one, I'm going to plug in negative 4, 3 again for x and y just to check my answer. 2 times negative 4 is negative 8. 5 times 3 is 15. Negative 8 plus 15 is 7. Does 7 equal 7? Yes, it does. Okay, because it worked for both of them, I know it's a solution to this system as a whole. Okay, so flip, let's do a couple more. So the first one here, I have negative 2x minus 9y equals negative 25. Okay. This one here, I have negative 4x minus 9y equals negative 23. Okay. So for my x's, I have negative 2 and negative 4. Okay. They're not the same. Here, I have negative 9y and negative 9y. Okay, it is the same, okay, but it is not opposite sign. Okay, so I want to change one of these negative 9s into a positive 9. Okay, and to do that, it's super simple. You can just multiply the whole thing by negative 1. Okay. So the first one will stay the same. Negative 2x minus 9y equals negative 25. Okay. In order to make the second one a positive 9, I multiply by negative 1. And what that does is it changes the sign of everything. So when I distribute the negative 1, I'm multiplying, right? So this becomes a positive 4x. This negative 9y becomes a positive 9y. And this negative 23 now becomes a positive 23. Now I can see that for my y, I have the same but opposite signed coefficient. Okay? And once I have that, I'm ready to go. I'm ready to multiply. Okay? Ready to add. Okay, so negative 2x plus 4x gives you 2x. Okay. This negative 9y plus 9y ends up being 0y, so it's as if it is no longer there. Okay, and then the negative 25 plus 23 gives me a negative 2. All I have to do now is divide by 2, and I get x equals negative 1. Okay. Then plug it back in. Again, it doesn't matter which equation you choose. Okay, you're going to plug in negative 1 for x. Okay, so I'm substituting it in. I chose the first one. Even if you chose the second one, you should still get the same thing. Okay. So I plugged in negative 1 for x here, and now I solve. Negative 2 times negative 1 is a positive 2. Okay. Then I'm going to subtract 2. Since this is a positive 2, this is a plus 2, I'm going to subtract 2. Okay. And then to get rid of this times negative 9, I'm going to divide by negative 9. Okay. And that gives me 3. Okay. So then write your answer in an ordered pair, x comma y, so negative 1 comma 3. Okay. Sometimes, right, it's not written in the form where it has x and then y and equals a constant, right? So here I have y equals negative 8x minus 16. This one I have a negative 3x plus y equals negative 5. Okay. So in order to make it all line up, okay, I need to change that top one and move it so that my x's and y's are on the same side. Okay. So what I'm going to do is move this negative 8x by adding 8x. Okay. These are not like terms, so you cannot combine it. Okay. 8x is by itself, y is by itself. So if you compare now, negative 3, this is 8, so it's still not the same. This is y also. They both have a coefficient of 1. Okay. So I'm going to leave the first one as it is. Okay. And since this is positive y, right, and this is positive y, I want to change it so it's opposite. So instead of plus y, I want this one to be negative y. I'm going to do that by multiplying by negative 1. Okay. And all that does is it changes the sign of everything. So this 8x now becomes negative 8x. This plus y now becomes minus y. So that way I have opposites. Okay. And then the negative 16 is now going to be positive 16. Okay. So then I'm going to add. Now that I have opposite sign, I can add it. Okay. So negative 3x minus 8x gives me negative 11x. The positive y minus y simplifies to 0. Okay, and the negative 5 plus 16 is 11. Okay. So for x now, divide by negative 11, you get x equals negative 1. Okay. Easy enough. I can plug it in to solve for y. Again, doesn't matter which one you do. Okay, so I'm actually going to use the y equals negative 8x minus 16, and I'm going to plug in negative 1 for x. Negative 8 times negative 1 is a positive 8. 8 minus 16 is negative 8. And then now just need to write it as an ordered pair, x comma y. So negative 1 comma negative 8. So with this one, you can probably see that was a lot of work, right? Because I had to change it, move the x's to one side so that way I have x and y and then the constant on the other, right? So this one, for this problem, you should probably be thinking, and you would be correct, right? This would have been a lot easier if it was just a substitution problem, right? So there are so many methods of solving. Some are faster than others, depending on what you're given, right? This would be a great example where substitution would be a lot faster, since we already had y equals on its own, okay? So let's do one more. Okay? So here's the last one here. I want opposite coefficient. Sorry, I want same sign, opposite sign. Okay? So for my x's, I see 2x, negative 5x. Okay? So not the same. Okay? Here I have positive 8y, negative 20y, not the same. Okay? So what I want to do is I want them to be opposite sign. Okay, you can get rid of the x's, you can get rid of the y's, it doesn't matter. Okay, you should still get the same thing. So I'm going to choose to do it opposite for the x's here. So 2x and negative 5x. Okay, I want 10, right? 2 times 5 is 10. Okay, so I want one to be 10x, the other one to be 5x. Negative 10x, sorry. Wait, what am I saying? Okay, I want this one to be 10x, I want this one to be negative 10x. Okay, so to make this a 10, I'm going to multiply by 5. Right? But what you do to one side, you have to do to everything else. Okay, so I'm going to multiply the top one by 5. So distribute. So 5 times 2x is 10x. 5 times 8 is 40. Big number there. Okay, and then 5 times 6 is 30. Okay. I want this bottom one here to be negative 10x, right? So that way it could eliminate or get rid of one of them. So to make this a negative 10, I'm going to multiply by 2. Okay. And so distribute. Okay. 2 times negative 5x gives me a negative 10x. 2 times negative 20y gives me a negative 40y. Okay. And then 2 times negative 15 gives me a negative 30. What you see? 10x minus 10x ends up being 0x. 40y minus 40y, it also ends up canceling out to be 0y. And 30 minus 30 is 0. Okay, so if I have no x's, I have no y's, that means I have nothing, right? And if I end up with something like 0 equals 0, I have infinitely many solutions. And you're like, wait, what? Okay, so let me show you, right, why it is, right? So if we think about it on a graph, we had infinitely many solutions when it ended up graphing as the same line, okay? And I want to show you how 2x plus 8y equals 6 and how negative 5x minus 20y equals negative 15 ends up being the same line. Okay, and I'm going to show you this by changing it into slope-intercept form. Okay, so I'm going to solve for y, right? I end up with 8y equals negative 2x plus 6, right? I want it in slope-intercept form, that's why I'm putting the x first. Okay? You cannot combine, not like terms, right? This one has an x, this one doesn't. Okay, to get y by itself, I'm going to divide by 8. Okay, that leaves me with 1y on this side. Okay, negative 2 divided by 8 is negative 1/4. So I have negative 1/4 x. And 6 divided by 8 is 3/4. Okay. So let's look at this other line when I change it, right? So I'm going to solve for y also. I'm going to add 5x here. Okay. I have negative 20y equals, I'm going to do 5x minus 15. Okay, that way it's in mx plus b slope-intercept form. Okay, and then to solve for y, finish off by dividing by a negative 20 here. This leaves me with 1y. 5 over negative 20 ends up being negative 1/4 x. And negative 15 over negative 20, that becomes positive, and 15 over 20 is 3/4. And what you can see is the equation of the line is the same, right? So if I were to graph this, it'd be the exact same line, which is why I have infinitely many solutions. That's why when I solved it with elimination, I ended up with an identity like 0 equals 0. Okay. So just to recap, when we're solving systems, we have 3 cases. It's either going to be one solution, no solution, or infinitely many solutions. If we were to graph it, right, our lines would intersect once. Okay, and what we know is that our slopes are different. Okay, and when we solve using substitution or elimination, we'll end up with x equals something and y equals something. Okay? Again, it is okay if it's x equals 0 or y equals 0. That's fine. That's still a solution. right? It just means that where they intersect might be the x-axis or the y-axis. Okay? Our second case is no solution. That's when we graph and we have parallel lines. And that means our lines never intersect. Okay? And what we'll learn eventually in other math classes is that our parallel lines have the same slope, but different y-intercepts. Okay? And that's what makes them parallel. Okay? And when you use substitution or elimination, when you have no solution, you result in something that isn't true, something like 3 equals 5. Okay? So when you're solving and you end up with 3 equals 5, when you're doing substitution or elimination, that's a no solution. Okay? And then our last case is infinite or infinitely many solutions. When we graph it, the lines intersect always because it's the exact same line. As a result, not only is the slope the same, but the y-intercept is also the same. And that's what makes it the same line. Okay? And when we're solving using substitution or elimination, we result in an identity, a statement that is always true, something like 3 equals 3. So that's it for today, guys. Have a great rest of the day. Bye.